Hello and welcome to Space, here from the Observatory of Paris, right in the heart of the French capital. We're here to meet astronomers working on the unique Gaia mission, which has been surveying over 1 billion stars around our galaxy, trying to solve some of the mysteries of the Milky Way. French astronomer Frédéric Arnoux is one of hundreds of scientists digging into the mountain of fresh data from the Gaia Space Telescope. The mission has just released the richest star catalogue ever recorded. The hope is that it will fill in some of the big gaps in our knowledge of the Milky Way.
This is our galaxy, the Milky Way, 100,000 light-years across, and we're around 26,000 light-years from the centre. We really don't know it very well. This is an artist's impression. We don't know the number of arms in our galaxy or where stars form. Gaia will tell us.
It's hoped Gaia will tell us a great deal. The ESA Space Telescope has taken high-precision measurements of 1,692,919,135 stars. That's over 10,000 times more measurements than ESA's previous mission called Hipparcos. It's a pivotal moment in astronomy.
All of a sudden, we have a huge sample of objects for which we have their distance, so we know their intrinsic luminosity. And from that, we can deduce their physical properties, which we tried to extrapolate with other methods beforehand. Just like that, boom, we have an answer.
To have such a star catalogue has long been a goal of astronomers. One major attempt began here at the Observatory of Paris in 1887, a project called La Carte du Ciel, producing these intricate star maps. Today, astronomers have a 1 billion-pixel telescope rotating quietly in a calm spot in space.
Gaia's 1.5 million kilometers from Earth, and it's aligned on an axis of Sun, Earth, Gaia. It rotates around itself every 6 hours with movements that mean that it's able to observe the entire galaxy. And so in a few years, we have a complete map of the sky. So there are 3 instruments: an astrometer that allows you to measure the positions, a photometer used to measure the colors, and a spectrometer, which allows us to measure the radial velocity. That's the speed at which the stars move away from or towards us.
This is the result, the view of our galaxy from space, the best image we've ever had of the Milky Way. Finnish astronomer Timo Prusti heads ESA's Gaia science team and talks us through it.
These are the real Gaia measurements. We are measuring the number of stars what we are observing at different parts of the sky. And what do we see? We see a flattened structure. That's our Milky Way. That's our the Milky Way disk. We see some dark patches on top of it. What does it mean? It means that there we see less stars. There are more stars, but there is dust in front of them, and that's why we don't see the stars.
The Gaia data has also been animated into this unique view of the Milky Way. It shows in accelerated form how the stars are moving through space and time in our region of the galaxy. Looking at this animation and studying the data, the astronomers are able to peer into the darkness and see things they hadn't expected.
Now we think our Milky Way galaxy is a disk with a spiral structure, everything beautifully rotating around. But what we see already with this Gaia data release, we see that the stars a little bit further from our sun, they don't actually behave that regularly as we anticipated. They are disturbed. Something has perturbed our Milky Way galaxy. We don't yet know what, but I can see a lot of studies will be concentrated on this specific aspect.
Having the ability to study our galaxy's history and future from within, from a vantage point inside the Milky Way, is promising a great deal of discovery in all areas of astronomy. François Mignard, one of the founding fathers of the Gaia mission, is hoping the fresh data on 1.7 billion stars will help solve one of the big questions. How many arms does our spiral galaxy actually have?
Il y a tous les ingrédients maintenant avec ce qu'on a donné dans cette remise de
There are all
données.
the ingredients with this data release, with the motions and the distances to study the arms. But not only are there arms or not, but also are the stars in these arms different? Were they born at the same time? Do the arms have a unique history? Are the arms the result of a merger with an external galaxy? It's these questions that people are going to try to answer, and the Gaia data is absolutely fundamental for this kind of study.
Astronomy has come a long way since this observatory was founded 351 years ago. Space telescopes allow precision measurements of objects millions of light years away, and we can see that everything is moving.
Nothing is fixed, everything moves. The Earth is turning around the Sun at 30 kilometers per second. That's 100,000 kilometers an hour. And then the solar system itself moves around the galaxy at 230 kilometers per second. That's massive. And our galaxy itself is in a local group, and it moves in this local group at 60 kilometers per second. And the local group travels at 600 kilometers per second. That's about 2 million kilometers per hour. That's huge. Everything is in motion.
C'est gigantesque. Tout est en mouvement.
The Gaia data release this spring marks a milestone in the study of the Milky Way. More is coming, with the spacecraft continuing to send down measurements 11 hours a day, and more data releases due early in the next decade. And now to the part of the show in which we take your questions about the universe and put them to the experts using the hashtag AskSpace. And we're here at ESA's headquarters in Paris with Luisa Innocenti. You're the head of the Clean Space Office. Luisa, we've had a lot of questions about space debris. Isaac Gutierrez would like to know, how much space junk is there actually out there?
Since 1957, when we have launched Sputnik, we have launched some 5,000 rockets, which have delivered around 8,000 satellites. Most of the satellites are dead. They have reached their end of life. Some of them are still operational, only around 1,200. Some satellites have also fragmented, and they have created smaller parts, smaller debris. And today we have some 29,000 objects larger than 10 centimeters, which are monitored.
We had another question from Ilaria Cinelli. She would like to know, considering all of this space junk out there, could we imagine recycling it in some way?
One day we will recycle. On the other hand, we are not there yet. We first need to learn how to capture debris. It's something which has never been done. It's something which is not easy. And once you learn how to capture, you can also learn how to refuel, change the parts, and all the rest. So it's a stepped approach, and in the meantime, we will also need to decrease the cost of it, and it will be done in the future.
Great, thanks very much for your answers. You can ask your questions about the universe using the AskSpace hashtag, and we'll try to answer them. And you can follow other space news on Euronews.com.